did. We're going to talk about this today. Here it is, Hypotenuse-Angle, HA, Congruence. And then we're also going to be using triangle sum theorem with some notes on the back. Reminder, triangle sum theorem says that all three angles in a triangle add up to 180 degrees. You should also make the card on page 347 right up there that you're going to make is angle side congruence theorem. And right now I've got nothing on the back, but I'm going to write the definition. I'm going to draw an example. I'm going to mark the page number so that if I see or need to use this card again on homework, mathia, test, whatever, I have the resources I need to get it done. Let's talk about this one. Okay, so we're using our learning goals for the week, and our learning goals for this lesson and video is exploring why these theorems work and exist. More triangle congruence theorems, and like good mathematicians do, we're going to reason abstractly and quantitatively. We're going to construct viable arguments and critique the reasoning of others, and it is up to us to be paying attention to that. More triangle congruence theorems. Let's explore whether you can use other combinations of side and angle measurements to determine whether triangles are congruent. Let's conjecture that you can determine two right triangles are congruent by demonstrating that the hypotenuse and acute angle of one triangle are congruent to the hypotenuse and acute angle of the other triangle. Let's also conjecture that you can determine two triangles are congruent by demonstrating that the two angles and non-included side of one triangle are congruent to the two angles and non-included side of another triangle. You know what? Someone stepped up. They said, I can figure this out. My name's Felipe, and I can prove both conjectures using the triangle sum theorem and the angle side angle congruence theorem. Well, I've got this card made, but I was flipping through my stack of stuff, this colossal stack of note cards here, and I realized I hadn't made an angle side angle congruence one yet. So I flipped back through my notes, and I realized that it wasn't anywhere in this lesson. That's what happens in geometry. We're halfway through the year, and you need to understand all of the things that we have been talking about this entire time. They're all vocabulary that you're familiar with. So what do you do when you don't have anything that's available for you? You use your book. So in the in the blue edged sections of the book, you'll find the glossary. And as I flipped through the glossary, I realized angle side angle congruence isn't in there. That's because, as important of a concept as it is, they actually put all of the postulates and theorems in a specific section in the glossary. And so the angle side angle congruence theorem gets its own definition. It's its own thing. We did an entire lesson on this one. If two angles and the included side of one triangle are congruent to the corresponding two angles and the included side of another triangle, then the triangles are congruent. What? That's a lot of words to try to understand and wrap my head around. I want to make sure that I can see a picture maybe, and there's no picture here. I also went ahead and highlighted the angle side congruence theorem. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. That's what we're going to answer or address today. And I made that note card. I made that note card based upon the definition that I saw on, well, I haven't made the note card yet, I guess, on this page. So then I flipped a little bit further forward. You know that a book has an index where it keeps a list of all of the terms that are being used. And so I found that the angle side angle congruence theorem is on page 180. Find that page in your book with me. Here we go. Flipping past our page 347, flipping down to page 180. Page 180, angle, side, angle, congruence. And I know that we processed this page back in the day, but now here we are working on our notes for this page. Here we are. Okay, so I have a note card here, angle, side, angle, ASA, congruence theorem. If two angles and the non-included side, it's what I read. So I drew it. I drew two triangles that match, and you can see that I've got this section where I've got two sides that are in between two angles. I've got a side in between those two angles, and it's a similar or matching side in between those two angles. For this reason, angle, side, angle, those two triangles should be the same. kind of like when you set them up and you construct the triangles with just these pieces of information, any triangle you make with these three pieces of information will be the same size no matter how many times you replicate it. Okay, that's on page 180. So I had to write that down on page 180. And now I'm going to flip all the way back to page 347 because here's a page number that references the angle-side-angle theorem way later on in the textbook. And that's what learning in this math class is all about, is making those connections across the different disciplines. Felipe says he can use this, right? He says he can use angle-side-angle, and he can use triangle sum to prove that the angle-side congruence theorem also works. So you know what? Let's go ahead and just try to follow his example. How would you do this? You probably do it like this. You should draw two triangles. We're going to draw four, actually, because we're going to draw a right triangle as well. I can prove both conjectures. Both conjectures he's proving are the right triangles are congruent, one, and the two triangles can be congruent by this other thing. Okay, two triangles. I'm going to freehand sketch it. Right, so I've got a triangle there, kind of like the YouTube logo, and a triangle there. I'm going to say they're congruent. And I'm going to say that they're congruent because I'm going to first of all identify a matching pair of sides. So pink was my matching pair of sides. I'm going to identify a pair of matching angles in both of those triangles. And I'm going to identify a second pair of matching angles. But the way that I'm identifying them, the pink side is not between them. How would it be possible, right? How would it be possible to show angle-side angle when the side that I'm showing is not between the two angles? Felipe says this would do the trick. You know, the triangle sum theorem says that all of the angles of a triangle add up to 180 degrees. Maybe you have that sentence when you're using this measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Let's label. Here's angle 1, here's angle 2, here's angle 3. Okay, in both triangles, this is angle 1, this is angle 2, and this is angle 3. And it turns out if 1 and 2 of the left triangle match 1 and 2 of the right triangle, then the 3's have to match because these two are equal, and you need the third angle to make 180 degrees. So really, I guess these two angles have to be the same. And then look at this. Now we have a side that is between two pairs of matching angles. So we really do get this diagram with these angles. It didn't include the third angle when we started, but using angle-side angle and triangle sum theorem, we can just kind of like acknowledge that if two of these angles match two of these angles, then the third angles have to match. Otherwise, they wouldn't make 180 degrees like the triangle sum theorem says. So therefore, angle side is actually another way to show triangle congruence, in that this diagram, triangle 1, triangle 2, we can identify that the side is not between the matching angles. Something along, green now, along this line. Okay, that's angle side. He also said that this hypotenuse and adjacent side, right? HA, hypotenuse and angle, hypotenuse and angle congruence theorem says that he could also prove them. Well, okay, so he's got the angle side angle theorem and the triangle sum theorem at his, at his use. So let's draw two right triangles. Try to draw them so they look congruent, because they should be congruent. Right angle. I'm freehanding it. If you are not good at freehanding, use a ruler. Okay, so there's two right angles. This one does look a little bit bigger, but we're going to imagine. Okay, put the right angle marking in there. That's a box in the corner. Box in the corner. And then this is the thing. We're saying that the hypotenuses match. So this hypotenuse and this hypotenuse match. And then we're saying that this angle matches that angle. So they're both the same size. But they're both also with a right angle, right? Those markings mean that all right angles are congruent. So this is congruent to this one. I don't even think he needs the angle or the angle side angle one. He doesn't need either of these. We already proved this scenario. Granted, it wasn't for a right triangle, but it was for angle side congruence. We've already got this example. It's a little bit flipped around, but two matching pink sides, two matching yellow angles, two matching green angles. Well, by angle side, when you have a hypotenuse and matching angle in two triangles, those two triangles are the same. That's the proof, which was proved by these two. Take a minute, make your own note cards. Make sure you get some highlight going on the angle side or angle hypotenuse congruence theorem. And then that you also get some note cards made for the angle side congruence theorem as well. Those two theorems, added them to our list, added them to our stack of stuff. That's it for activity 4. Stick around for activity 5, and let's keep going. Thank you for learning some math today. See you in the next video.